Quick disclaimer, Learn from Mac is an independent educational project. We are not affiliated with, endorsed by, or sponsored by Apple, or any vendor or product covered in this course. Hey, welcome back to Learn from Mac. I'm Dennis, and today is day 16 of the F5 LTM R4600 Bootcamp. Today, one virtual server fronts multiple application tiers, content switching, built two ways, an iRule and an LTM policy side by side. Let's get into it. First, the goal. By the end of this lesson, a single virtual server routes requests to different pools based on URI path, HTTP method, and header value using both an iRule and an LTM policy, so you can compare them directly. Here's what you need. At least two distinct backend pools already defined, an HTTP profile on the virtual server, content switching needs that to parse layer 7 at all, admin TMSH or GUI access, and day 15's iRule fundamentals fresh in mind. 3 concepts before we build either version. Concept 1, content switching itself. This is a virtual server's ability to inspect layer 7 attributes, URI, method, host header, custom headers, cookies, and select a backend pool based on them. One VIP can front multiple distinct application tiers without needing a separate IP for each. Concept 2, iRule pool selection. Inside an iRule, the pool command overrides the virtual server's default pool. Evaluated at HTTP polish request, it gives you full TCL logic, conditionals, data group lookups, string operations to route anywhere. The trade-off is real. iRules need a developer mindset and carry a higher per connection CPU cost than LTM policy. Concept 3, LTM policy as the alternative, a declarative GUI manageable rule engine, ordered rules, match conditions, forward actions, compiled natively, no TCL overhead. For straightforward URI or header-based routing, this is usually the better choice. Save iRules for logic that's genuinely too complex for a condition action model. All right, 3 labs. First, an iRule doing URI and method-based routing, tested live. Then the exact same routing logic rebuilt as an LTM policy, host, path, and a static asset rule together, so you can see both approaches side by side. Then we add a new routing rule to that policy through the REST API without touching the original config at all. Let's get into it. Lab 1, an iRule routing by URI first, then by method with a default fallback. Attach it, then test all 3 paths live. A post to a non-API path still routes to pool API on method alone. Lab 2, the same routing outcome, this time as an LTM policy, API path first. A static asset rule and a catch-all default. Publish it, swap it in for the iRule, and confirm it's active. Send the same test traffic, then check the policy's hit counters. Lab 3, add a new routing rule to the live policy through the REST API, health checks to a dedicated monitoring pool. Editing through REST, put the policy back into draft, republish to actually activate it. Verify the new rule is present, and save. And that's the same content switching outcome, built 2 different ways so you can actually feel the trade-off. There are self-check questions on the lesson page worth sitting with, when an iRule's flexibility is actually worth its CPU cost, versus when LTM policy is simply the better tool. Take a minute with those. Quick recap before we go. Content switching lets one VIP front multiple application tiers, no separate IP per tier required. iRules give you full TCL flexibility at a real per connection CPU cost. Reach for them when the logic genuinely needs it. LTM policy is declarative and compiled natively, the better default for straightforward URI, method, or header-based routing. And editing a published policy through REST puts it back into draft, always republish or your change never actually takes effect. All right, that's day 16 in the books. Content switching built with an iRule and an LTM policy, both tested and compared directly. That's an informed architectural choice now, not a guess. If this was useful, hit subscribe. You won't miss a single lesson. Next up is day 17, One Connect and connection pooling. See you there.